Okay, so let us start our session, this session. We have some technical problems, but I think we will fix them, no problem. So the next talk is by Mehsin Atteya, and the talk is the title of the talk is Characterizing of Linear Mappings through Unital Algebra.
Okay, thank you so much. First of all, I would like to say thank you so much for the organizer to give me this great opportunity to meet you. Today I'm so happy to present my presentation, which is under the title Characterization Linear Maps Without Unital Algebra, and the abstract of this. My abstract, the main of this presentation in this paper, we characterize two linear maps, sigma and tau, satisfying the identity x circle y power star equals 0 plus this implies to this relation here sigma and sigma of x circle y power x plus x circle tau of y power circle for all x, y element to A, where A is an algebra over a real or complex field K from unital algebra to it is an unital bimodule. And the background of this subject, we find the structure of linear maps behaving like Jordan divisions at the commutative zero products has been studied extensively. We refer the researcher, like this is a sample of the researcher who worked and posted more results about this subject. As is well known, the problem of linear mappings preserving fixed product is very interesting items in the field of the operator algebra. A derivation that can be completely determined by the local action on some subset of algebra have attracted attention of many researchers. Historically, the study of derivation was initiated during the 1950s and 1960s. Derivations offering got a tremendous development in 1957 when Posner established two striking results in case of prime ring, where in this he make prime ring commutative. Also, here we only focus on derivable mappings at the special point. There are considerable number of the influential results on derivable mappings at zero, unital, invertible elements, rating points, idempotent elements, and so on. And some result, derivable mapping at zero is described in the terms of generalized derivation. And references 9, the author described continuous derivable maps at zero on von Neumann algebras. It was studied too in the reference 16 for continuous derivable mappings at zero from unital C-star algebras into unital Banach bimodule. Again, in reference 17, discussed continuous derivable mappings at the arbitrary but fixed product on von Neumann's algebras. In the references 11, Leo considered continuous derivable mappings from unital Banach algebra into the unital Banach bimodule at left or right separating points. Furthermore, the authors in references 15 generalize this result without the assumption of continuity. Moreover, Lee and Leo in references 13 with this is updating, or this is a recent result in this subject. They gave a complete description of linear maps sigma and tau from G, which is algebra, into and satisfying these relations. here sigma A B star plus sigma A tau B star equals 0 for any AB in G with this relation A B star A dot B star equals 0 or equivalent this relation, where this here circle, some print A circle B right by this way. This is formula is called Jordan product. Throughout this paper, little AB and associated algebra over complex field. Some paper have structure of derivable mappings at zero Jordan products. I think I submit this. I speak about this simple circle, which A circle B right by the way. This is formula Jordan product. A linear mapping sigma from G into A is Jordan derivation mapping at zero Jordan products if A circle if sigma of A circle B plus A circle sigma B equals 0 for all A, B, and G with this identity A circle B equal 0. This means here Jordan product equal 0. Let us fix some more notation. A linear map sigma from G into A is called a derivation sigma AB equals sigma A plus B plus A sigma B for all AB in G. The sigma is called Jordan derivation if just replace B by A and apply the same definition for all A in G, which is equivalent to this formula. In fact, Jordan derivation and Jordan has a strong relation, and the reader, you can find more and more papers which discuss about the relation between derivation and Jordan derivation. In addition to that, also we have Lie derivation, which has a specific definition. It's clear that every derivation is Jordan derivation, but the reverse converse is not true always. Beside on the linear map sigma from G to A, call the Jordan left derivation. This is here left derivation. Sigma A square equal to A sigma A. An element W in G is left or right separating point of M if WM equals 0 or NW equals 0 implies A equal M equals 0 for each M and M. W is called separating point of W is both left separating point and right separating point. It is easy to see that the left or right invertible elements in G are left or right separating points of M, and invertible element in G are separating point of M. Proceed on references 14. We denoted T of G for the subalgebra of G generated by all idempotents in G. Be an algebra in A by module M is said to have the probability diamond if there is an ideal G subset in her T of G of A, such that we have this relation. Also, we need to the definition of weak inverse element in the theory of semigroup. Weak inverse element of element X in the semigroup is an element G such that X with Y, sorry, X with Y have this relation Y equals 0 equal Y. If every element has a weak inverse, then versus or E Dennis symbol. Now this type of main results, we begin our discussions with the following result. This is lemma from references 14, theorem 3.3. I will depend on this lemma during my work to achieve my result. F theta bilinear map from G cross G into vector space guy such that A, B, and G, A circle B equals 0, equal theta A, B equals 0, then we have this relation. And the first theorem, let A be a unital algebra and M be a unital A bimodule with the probability diamond with mentioned previous. Suppose that sigma is linear map from A into M, satisfy the relation for relation for all A for all xy in A, x circle y equals 0 plus 2 delta x circle y minus x circle y equals 0, and each element of A has a weak inverse, then A has 0 ideal. Second theorem, I let A be a unital algebra and M be a unital A bimodule with the probability diamond. Suppose that sigma and tau are linear mappings from A into M, satisfy the relation here x y in A circle y equals 0, and sigma x circle y plus x here plus not minus x circle tau y equals 0, and the bracket, this is commutator A with the subtraction between two maps, mappings, sigma take away tau equals 0. Then there exists a Jordan derivation delta from A into M such that Jordan derivation equals 0 for every element in the unital algebra A. The last result, let A be a unital star algebra and M be a unital star A bimodule with the probability diamond if sigma and tau are linear maps from A into M, satisfy the relation here x circle y star in this case equals 0, sigma of x circle y power star plus x here circle tau of y power star, and A is separating point of LM, then there exists, then there exists this result. We find A delta of A equals 0. Finally, I closed my presentation by the list of references. Hopefully, it can enrich any people interested in this subject and to get more information. Thank you so much for your listening.
Thank you very much for your talk.